So we're going to change gears here a little bit. We've spent all of our time so far this triad solving equations. So we started out first triad solving simple one-step equations, and then this triad we've looked at more and more complicated equations, ones that we have to do more than one step, ones that have square roots in them or squares in them or has variables in different places. So we've looked at a lot of different types of equations and how we solve them. But we haven't talked really about checking our answers and making sure that we're getting the right answer. All right, so what we're doing when we solve an equation is we're trying to figure out what number we can substitute for the variable so that the equation is true. And sometimes if we make a mistake, we're going to get a wrong answer. Or sometimes we're going to see equations that don't have an answer, that just don't have a solution at all. This one right here from the opener is actually an example of an equation that does not have a solution. There is no number that we can put in here for e that's going to work. Now, does anybody know how I could check that? How I could check to see that this 13 here that we got at the end either works or does not work in that equation? What we can do is we can take that 13 and put it in for the e, so we can forget about all these steps that we did in between here and focus on just the answer. And I can replace what I have in the equation, the e, with 13, and simplify everything. And if I put 13 in here where the e is, and this equation ends up true, we get the same thing on both sides of the equation, then 13 is a correct answer. If it turns out that I get different things on each side of the equation, then 13 is not the correct answer. And like I said, sometimes that's going to happen because we made a mistake and we'll have to go back and try to figure out what happened. There are rare circumstances, rare situations where an equation does not have a solution. And this is one of them, and we'll talk about this one in a minute. All right, so here's what we're going to do. I want you to get these notes down first. In order to check your solution to an equation, these are the things that we want to do. We want to substitute the answer that we got, the solution that we got in for the variable in the original equation. Then we're going to simplify each side of the equation using the order of operations. And if we get the number on both sides, it works. Okay, so if we get the same thing on both sides of the equal sign, it's good. If we get different things, if we get something different on the left side than we get on the right side, then it wasn't right. So we're going to have to figure out why it wasn't right when that happens. Okay, so let's do this. So here's an equation, and what I did is I solved this equation. I got an answer here, and I want to check to see if my answer is correct. So we're going to follow those steps that we just did. So I want you to write down that equation for example 1, and then off to the side put the answer. Now, why did I put the a equals negative 9 over here instead of underneath it?
Because we need to check.
Well, when we check it, our work is going to go underneath, right? So when we put the negative 9 in for a, when we substitute it, we're going to put that in right underneath it here, and then we're going to simplify each side of the equal sign. All right? So I'm going to go ahead and plug it in. Everything is going to be exactly the same, except I'm going to put a negative 9 in wherever I see an a. Does that make sense? All right, so let's go ahead and do that. So we've got 4 parentheses, and then we've got a negative 9 there, right? And then minus 3, parentheses, minus 3, open parentheses, 2, negative 9, minus 4, parentheses, equals 18. So I just rewrote this equation, and anywhere I saw an a, I put in a negative 9. Now I've got one problem here. To me, this looks like it's 2 minus 9 here. Is that what it's supposed to be? 2 minus 9? What's it supposed to be? 2 times 9, 2 times negative 9, because this was 2 times a, right? So to show that, I'm going to put that negative 9 in parentheses. What some people like to do is anytime they substitute, put it in parentheses. So we would put the negative 9 in parentheses there. You don't have to do it every time, but any time that it looks like it might be a different operation than what it's supposed to be, those parentheses can be helpful. All right? So that's the first step. Second step says simplify each side using the order of operations. Do I need to simplify the right side? No. Is there any way I can simplify the number 18? No. So what I'm really doing is I'm going to simplify the left side. I'm going to do something that we always do when we solve equations. I'm going to draw a line of equality here. And I can just forget about the right side. I don't need the right side because it's already simplified. But what I need to do is simplify the left side. So using the order of operations, what am I going to do first? What's the mnemonic, the acronym that we use for order of operations? You guys remember PEMDAS? We use that for order of operations. So we got parentheses, exponents, multiply, divide, add, subtract. You guys remember that? Okay. So we're going to use those order of operations to simplify this. So we're looking for parentheses first, and we have it in two different places. In this parentheses here, what's negative 9 minus 3? Negative 12. So we're going to replace that negative 9 minus 3 with a negative 12. Okay, I'm going to keep it in parentheses though because we have that times 4 on the outside. How about here? We're going to do two steps at once here. Inside of this parentheses, am I going to do my multiplication first or my subtraction first? What comes first, multiplication or subtraction? Multiplication. So what's 2 times negative 9? Negative 18. And then we have negative 18 minus 4, which is? So we get negative 22 in the parentheses here, and then on the outside of that we have our minus 3. All right, now what? We actually don't need to do that. You can if you want. You can keep bringing down the equals 18 if you want. But all we really need to do is simplify the left side. We can ignore the right side. It's not like we're solving an equation. We don't have to use the golden rule here. We're just going to keep each side separate. So let's just keep going with the left side. What's the next thing we do after we take care of parentheses? Are there any exponents to take care of? No. Okay, how about multiplication or division? There's some multiplication, right? So one of the multiplication we have is 4 times negative 12, which is?
48.
Nope. 4 times negative 12 is? Negative 48. And then negative 3 times negative 22 is? Positive 66. All right, so we've got multiplication and division done. Now we're on addition and subtraction. What is negative 48 plus 66? You can punch that in your calculator and you get? Positive 18. All right, so what do you think? Did this work or did it not work? Is this the correct answer right here? Yes. Why? How do we know it's the correct answer? Brian? Since we started with 18 on the right side and we didn't have to simplify anymore, that's what we had, and we simplified the left side and we got 18, we got the same thing on both sides, right? So step number 3 says if you get the same thing on both sides, then the answer was correct. So what we're going to do to show that our answer was correct is we're just going to put a check mark next to the answer there. So we have the a equals negative 9. I'm going to put a check mark right by the box where I boxed my answer to show that I checked the answer and it was correct. This one is really similar, so I want you to try it on your own. The only difference is you're going to have to simplify on both sides. So the first thing we're going to do is we're going to go through and anywhere we see a b, we're going to put a 2. All right, so I'm going to do that on both sides here. We have 3 times, and then we're going to put a 2 in there, minus 2 plus 7 equals 5, parentheses, 2 plus 1, and close parentheses. Now, there's one place here where I put a 2 in that makes it look like 22 instead of what it's supposed to be, so what should I do? Put parentheses around it. So instead of writing 22, we want to make it 2 times 2, so we'll put parentheses around that. All right, now, once I do that, I'm going to draw my line of equality again. So I want to separate the left side from the right side, and I'm going to simplify each side now. So I'm just going to do one side at a time. On the left side, we're going to do order of operations. Okay, so we'll start with parentheses. Do we have any parentheses here?
Yes.
Yes. In that parentheses, we have 2 minus 2, which is? What's 2 minus 2? 0. So we get 3 times 0 plus 7. And let's go ahead and just finish the left side, and then we'll go back over and do the right side. So on the left side, what's 3 times 0?
0.
That's 0. So we get 0 plus 7. And then 0 plus 7 is? 7. So our left side is 7. All right, that means that if this answer is going to be correct, we should get 7 on the right side. So let's see if that happens. On the right side, we've got parentheses again, right? So inside of the parentheses, what's 2 times 2? 4. And then let's go ahead and do the whole parentheses. What's 4 plus 1? 5. So in the parentheses, we get 5. And then outside of the parentheses, we have 5. And 5 times 5 is? 25. And that's it, right? So is this the correct answer? No. What do you think I should do to show that that is an incorrect answer? Yeah, we're going to put an X. We're not just going to put an X like that, but we're going to put an X through the whole thing. That is not a correct answer. We're just going to put an X through it. Now, there's a couple of reasons that we might have gotten an incorrect answer here. It's possible that there's no solution to this equation, and so that the answer we got is not correct. It's more likely that when we solved the equation, we did something wrong. So if that's the case, if you solve an equation and then you check it by substituting and you get a wrong answer, you're going to want to figure out why you got the answer wrong. All right, you don't want to just leave your answer incorrect. This is a way of checking to make sure you did it right, so if you got it wrong, you can go back and fix it. All right, so there's two things we're going to do to show that the answer is either right or wrong. If the answer is correct, we're going to use a check mark. If the answer is wrong, we're going to use an X. Moving on. I want you to check to see if this is the correct answer. Now, this is actually an equation that you probably wouldn't be able to solve on your own, but you can still check to see if an answer is correct by using these methods that we're talking about. So I'm going to rewrite the equation, but I'm going to put 4 anywhere that I see a D. So I've got 2 to the 4th power minus 1 equals 14. Now, do I want to add 1 to both sides to get rid of the minus 1, or use the golden rule to do the same thing on both sides? Do I want to do that? Nope. What I want to do here is I want to simplify each side of the equation. And actually, one side is already simplified. Which side don't I need to do anything with? The 14, right? The right side. We don't need to do anything with this because that's simplified. So we just need to simplify the left side and see if we get the same thing as we had on the right side. So the first thing we're going to do is the exponent or the subtraction? Exponent, right? Remember PEMDAS, parentheses, exponents. So exponent comes second. There's no parentheses. So let's go with the exponent. What does 2 to the 4th power mean?
2 multiplied 4 times.
Yeah, so it's 2 times 2 times 2 times 2. What is 2 times 2?
4.
Times 2?
8.
Times 2? 16. So 2 to the 4th power is 16. So we get 16 minus 1 here. And then we'll do our subtraction. What's 16 minus 1? 15. So we get 15 on the left side and we get 14 on the right side. So
It's wrong.
it is wrong. So we're going to put an X through your answer. Now, for what we're doing now, all you have to do is check if it's right or wrong, and that's it. When you're solving equations yourself, when you get a wrong answer, you're going to want to fix it. All right, it's not enough to say, well, the answer I got is wrong, so I'm just going to quit. That's not good. If you get something like that, then you need to fix the answer. All right, let's do one more here. I want you to try to do this one on your own.